spirit, okay, we wanted to express the fact that that particular curve that has been traced by this vector, okay, this vector, okay, that I'm going to write in terms of as a parametric representation. I'm going to write it as a parametric representation, okay. So in parametric form, okay. So all right. So what we will do is we can so if you recall the vector is the vector that I'm talking about is a b and c0u plus c1, right? Okay. So this is parallel to x-axis. This is basically x component. This is y component. This is z component. Okay. So that would mean that I can define any a parameter, some parameter. Let's call that parameter t. Okay, such that dx, but if dx by dt happens to be a, then dy by dt has to be equal to b, and dz by or du by dt. So I have third direction, which is u or z, call it z, what we are calling u, which are same. So du by dt should be equal to c0u plus c1. This has to be satisfied. These three. If I so what I'll repeat again. If I define a parameter t such that x varies with t in this manner, okay, then y and u must vary like this. Okay, then only this x and y and u will simultaneously vary, so that the curve will be tangent to this vector always. Okay, is that all right? Is this argument okay with everyone? Okay. So I'll just give you 10 seconds for this to sink in, and we'll proceed. Okay. This is probably very key part of this entire discussion. Okay. So writing it in a parametric representation. So this particular hypothetical parameter that this t that I'm writing here, I'm going to call it time lag variable. This is time lag. It can be anything, any parameter. It can be angle, theta, whatever. I don't understand. Du dt, you didn't understand. Oh, okay. Let me just okay. Express this. So what I'm saying is, so let's say I have a vector. Let's say v1, v2, and v3. Okay. So if I have a vector v1, v2, and v3, this vector is v1, v2, v3. v1 is, well, let's call it vx, vy, vz. Okay. So v1 would be, sorry, okay. So I know that this would imply dx by dt that should be equal to vx, dy by dt should be equal to dy, dz by dt that should be equal to dz. That's all I have done here. So here I have vx, vy, vz, dx by dt, dy by dt, dz by dt. Z and u are the same. If you recall, I'm placing myself in x, y, u space. Z equal to u of x comma y. If you recall that. Remember this equation. So that's all I have done. Okay. Yeah. Thank you. So yeah. Oh, okay. That was a confusion. I thought. Okay. Yeah. So remember, I'm going to. So when I have to express the solution function, I will say u. But if I have to express the geometry, that is like surface height, etc., I'll express it as z coordinate. Okay. So z and u will be used interchangeably. Okay. Okay. Any other question? All right. So okay. I guess that is. So but this representation of this parametric representation is fine with everyone, I hope, right? All right. So now having said that, now what we have here is essentially, okay. Thank you. So thank you, Amit. Yeah, let's proceed then. So having said this, what we have now here is, now if I know, so these are what? These are basically ODEs in x, y, and z, x, y, and u variables, right? These are independently 3 ODEs, right? So these are easy to solve. So now if I know, let's say, if I know at parameter value, if I take t equal to 0, I know the x value and y value and u value. Okay. If I know these values at the parametric value of t equal to 0, then I know how x will change with as we change the parameter, and simultaneously how y will change as we change the parameter. Okay, and as a result, you will know how your u will change as you change the parameter. Okay, so basically you can solve for u. You can get rid of the parameters and you can actually eliminate the parameters, and you can find u as a function of x and y. Okay, so knowing initial condition in x and y. Initial, well, I would say initial would mean that the parameter value, which I'm calling time like, it need not be time exactly, but it's time like. So you're just calling it something which is analogous to time, but it need not be actual time. Okay, so it can be anything, right? So we're just naming it time like variable, right? So this would mean that at some value of t, which we call as, let's say, which we assign as t equal to 0, if you know x and y and u, that would mean that u can be solved as function of x and y. You'll see the example, then probably it will become more clearer to you. Okay. 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 Then. Okay. So now, so here. Uh, okay. So what you need is basically uh, that initial values of x, y, and u, right? So need essentially let's say uh, x, y, and u value at t equal to some specified, let's call that 0. Need not be 0, some specified value of the parameter. Okay? Some specified value of the parameter which is arbitrarily chosen as 0. Okay. All right. So what does that mean actually? So that would mean actually it's like something that I told you earlier. Uh, so it tells me what. So it just imagine this. Suppose I have x, y, and u space or z space. Okay. U. Okay. So x is a function of t, y is a function of t. So as I change t, x will both change in certain manner, right? So that would mean that at t equal to 0, let's say x is known, y is known, and as we change, well, so let's see. So what you have here is actually, so now, okay, alternate way of looking at this would be, if you have x as a function of t, y as a function of t, and u as a function of t. What kind of geometrical object will this describe in XYU space? Is this a point, line, surface, volume? What is that? Can anyone tell me now? If I know x has a dependence on t, y has a dependence on t, and z has a dependence on t, what kind of any answer? So let's see. So here, how many variables do we have here? Number of variables? Yeah, that's correct, Pawan. Yeah. So number of variables is 4. Number of equations, 3. X as a function of t, x will be some function of t. So among these variables, there are 3 interrelationships existing, right? Yeah, so therefore, degrees of freedom would be 1. Okay. So degrees of freedom would be one, meaning that there will be a curve, line, okay, line in three-dimensional space, curve in 3D space. Okay, and how do you trace this line? So for example, let's say at t equal to 0, I have some x equal, so say x t equal to 0, y at t equal to 0, and u at t equal to 0 specific. Okay, that would mean that in this figure you may have something like you can imagine probably, okay, some point over here, let's say. Okay, this is t equal to 0 point. Okay, t equal to 0, I have certain x, y, and u values. Okay, so this would be for u values at equal to 0, and this, if I know this, then this will, as time progresses, from here I know how x, y, and u will change, so it's going to trace a curve. Okay, so as x and y and u simultaneously change, okay, as they simultaneously change according to the fixed rule obtained by dx by dt, dy by dt, and du by dt, which we saw in the previous page, right? Then if you change x, y, x, y, and u simultaneously, then they will all trace a single curve. Okay, from the starting with the first condition, initial condition. This is nothing but actually. So what I did was algebraically what I did was I solved uh, is these three ODEs independently in terms of t. So I obtained x as a function of t, y as a function of t, u as a function of t. So I had three equations: x as a function of t, y as a function of t, u as a function of t. And then I eliminated out of these three. I have four equations, three unknowns. I eliminated one of them. I got an equation which would be actually an equation of curve in three-dimensional space. Okay, so I just got rid of uh, so basically I got, so I can get rid of t in these three equations. I can express u as a function of x and y, okay, and u as a function of okay, so well yeah, u as a function of x and y. So for every x and y there is a u, okay, and that would give me a curve, right? So that's how you get the curve, right? So you have t, having eliminated t, you will get a curve. That's so four variables, three equations, 1 degrees of freedom. That's a curve. Okay, is that all right? So you get a curve. Giving an initial condition, you get a curve, right? So that will give me a curve. Curve is obtained by changing t, okay, and simultaneously changing x, y, u according to the ODEs obtained from geometrical analysis. Right? That's what we did previously, right? So okay, so now so that would mean that if I had an initial curve node, so at equal to 0, let's say I have bunch of x, y, and u values known. Okay, so say I have initial condition known. Okay, so if there was an initial curve, there's an initial curve, not this curve that I've shown up here. No, I have an initial curve. Okay, so initial curve would mean what? So initial curve would mean that at t equal to 0, x, y, there is a, in x, y, z space, there is a u is varying with x along x and y on certain curve on an xy xy plane, right, in certain manner. Okay, well let me just show that probably in terms of picture. So so initial curve would mean I have, let's say, x, y, and space, okay, and t equal to 0, I have, let's say, X and Y have, you can imagine certain curve in XY plane. Okay, let's complicate it. Okay, so this is, let's say I have a curve. It's complicated. It's easier to draw for me. So let's say there's a curve that looks like this. Okay, now this is my initial equal to 0, next some curve at t equal to 0 in xy plane. Okay, and each x and y, I have some unique value of uh, okay. For example, here I have this value, here I have this value. Okay, this would be a so this would be a xy, in xy plane. This you can identify a curve, and for each curve, each point on this curve, I can assign u values. So this would be your t equal to 0, and this is called initial curve. Okay, or also termed as, we are going to call it gamma curve. Okay. Okay, so that would mean that basically at t equal to 0, okay, u will be a function of, so you can say that, let's say I am going to express this as, this curve can be expressed as x, at t equal to 0 and some other parameter s, y at t equal to 0, some other same parameter u. Okay, this would be your initial curve. So this is but a parametric representation of the initial curve. Okay, these are just set of y values of u at t equal to 0 for different choice of x and y. Okay, so when I have, so that's all. Okay, so this is my initial curve. Now what is, uh, so well, if it's probably do, I can probably relate this to a simple example. So example, if you remember heat equation, okay, so you have heat equation. I had del u by del t, v square u by del x square, right? And the conditions were given as, so imagine you had a bar, right? So I had given this example before. So you had a bar, okay, and let's say at left end, okay, as time progresses, okay, so this is my x direction, okay, and let's say I'm going to express my u this way and t will be this way. Just a minute. That is okay. 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 So here, what I was referring to is, for example, this is x versus t. Let's think of a time axis going inside. At each time, U may be temperature, so U is the same as temperature or concentration. Okay, so temperature would be controlled at x equal to 0, let's say, okay, as some function UL of t. Okay, so this would be your, at left end, I'm controlling my temperature. I know how temperature changing with time. Okay, and at right end, I know how temperature is changing with time. That I can control myself. I have some device available, and that is able to control ULT and URT, etc. Okay, so they need not be the same, so they can be different. Okay? So let's say I have some kind of relation. So, okay. So I have some kind of variation on right end, left end, and so if you look at this, what you're doing is actually identifying a curve. So now this t is like y in our analysis. Okay, I have two independent variables. Remember, we were calling x and y. So here x and t are my variables. So y is like t. Okay, and in this xt plane, that means xy plane, this curve that I've identified is nothing but the t-axis itself. Okay? That t line is my presumed curve now. Okay? That is, that would be y equal to 0, or here well, here it is x equal to 0. Okay? So here x is like t and y is like x, etc. So we can establish a correspondence. So so this would be, what happened?